9 a.m. Sailors wait for the first breath of wind. As yet, there's not a breath to be felt. In the meantime, there's plenty of work to be done. They know it's only a matter of time before the wind kicks up. But where is the wind? Is it out there, beyond the harbor, working its way slowly toward the land? Wind is air in motion. You can't see it, but you can see its effect. So you can see what wind does, but how do you study something you don't really see? One good way of studying wind is to look at water. Because air and water are both fluids, they behave much alike. A similarity filmmakers use to create special atmospheric effects. Atmospheric scientists use tank simulations to study wind. The fluid is set in motion by a heat source. As the water warms, it rises, and surrounding water moves in to take its place. This kind of flow pattern, produced by heat, is called a convection cell. The same thing happens in the atmosphere. Here, a hot, sun-baked field produces a convection cell. Its rising column of air is called a thermal. By searching out thermals, soaring birds can travel hundreds of miles without flapping a wing. And they aren't the only ones that ride thermals. Climbing at 5 meters a second, a sailplane can soar high into the sky. The pilot maneuvers his craft carefully, keeping it within the rising currents of air. The sun-warmed land below is the heat source for this small atmospheric convection cell. A greater mass of air rises from a sun-warmed tropical island. As the sun comes up, it heats the land, causing air over the land to rise. This warm rising air draws in cooler air from over the water. This sea breeze may blow in from all sides, and the moist rising air produces a towering stack of cumulus clouds. Then at night, when the land cools, the wind reverses. Since it now blows from the land side, it's called a land breeze. Along coastlines, the same thing happens. It's now late morning. The sun has heated the land and the convection cell has formed. The awaited sea breeze has arrived. It's a fine breeze. Out of the harbor, wind fills the sails, bringing hours of steady sailing from wind generated by this giant convection cell. Steam from a nearby power plant shows the direction of the sea breeze. Wind will hold steady all afternoon, but as evening falls, it gradually stops and reverses direction. Here, the daily land breeze, sea breeze cycle creates coastal winds, but In other parts of the world, a sea breeze-like pattern follows a seasonal cycle and affects entire continents. As the continent of Asia soaks up summer heat, air begins rising. This huge atmospheric convection cell draws in moist air from surrounding oceans. Clouds swarm over the land, bringing monsoon rains. Welcome after many months of arid conditions. Nearly half the world's population depends on the monsoon for life-giving water. Of course, some places get more rain than others. To the village of Cherrapunji in India, the monsoon wind brings a particularly heavy load of rain. In a heavy monsoon season, Cherrapunji receives some 25 meters of rain, over 80 feet of water. Some winds sweep over the entire globe year-round. Near the equator, the tropical sun generates the largest convection cell on Earth. The return flow from this convection cell is deflected by Earth's spin, forming the trade winds. And in the mid-latitudes, where many of us live, prevailing westerly winds form great bands. Embedded in this prevailing flow are the storm systems which bring rain and snow. So wind, from coastal winds to monsoons to prevailing winds, is set in motion by heat. But once in motion, a wind's flow can be affected by obstacles, like mountains. Rising thousands of feet, mountains change the flow. Twisting, bending, swirling around, the wind becomes erratic, changing direction and stirring up the powdery snow. Where wind funnels between mountains, it picks up speed, sometimes with enough force to tumble rocks and blow down trees. But now and then, an unusual mountain wind sweeps down, bringing a day of warmth in the middle of ski season. It's called a chinook. The chinook occurs when air rising up one side of a mountain loses its moisture in rain and snow. Flowing over, this dry air is compressed by the weight of the atmosphere above, causing its temperature to rise, melting the snow. A much colder type of wind begins in the still of high mountain plateaus. Here, protected by the surrounding mountains, air gathers for weeks, taking on the temperature of the frozen land. Then, set in motion by its own weight, this icy air spills over with chilling effect. When wind flows over a range of mountains, it's pushed up into a mountain wave. These saucer-shaped clouds indicate that a strong wave is building. Sailplane pilots carrying oxygen have ridden these mountain waves to 46,000 feet, 14,000 meters. Along a coast, cliffs also create a wave of air. These gulls hover leisurely in the updraft, like hang glider pilots who use these waves to stay aloft for hours at a time. Wherever the wind blows, people have learned to harness its power. wind, air set in motion by the energy of the sun.